Hey everyone, and welcome. Today we're going to talk about something called concentrating solar power, or CSP for short. And it's a really cool idea. The goal? Basically to bottle up sunshine so we can use it, long after the sun's gone down.
Now, when you hear solar power, you probably think of those panels on your neighbor's roof, right? Well, take a look at this. This is something else entirely. We're talking industrial scale solar here. Just look at that field of mirrors stretching out as far as the eye can see. And they're all pointed at one thing, that single glowing tower. And it's that incredible scale that unlocks this really powerful idea. Seriously, what if you could grab the sun's intense heat during the day, stick it in a tank, and then pull it out to make electricity whenever you want, even in the middle of the night? That right there, that's the whole promise of CSP.
Okay, so here's what we've got on tap. We'll start with how this is different from regular solar panels. Then we'll check out the 4 main ways they do this. We'll uncover CSP's secret weapon for round-the-clock power, take a quick trip around the globe to see where they're being built, and wrap it all up by looking at the good, the bad, and the future of sunshine.
All right, first things first, how does this even work? Well, the magic of CSP isn't what you might think. It's not about turning a light directly into electricity, it's all about capturing its heat.
So here's the key difference, and it's a big one. A standard solar panel, that's called photovoltaic or PV, it takes sunlight and poof, turns it straight into electricity. But CSP? It takes a totally different route. It uses sunlight to create some serious heat first. And from that point on, it's actually a lot like a normal power plant. It just uses that heat to make electricity. But its fuel is the sun, not coal or natural gas.
Okay, so let's trace the path of that energy, shall we? You've got all these mirrors focusing sunlight onto one spot, the receiver. That gets incredibly hot. That heat then gets transferred to boil water and create steam in a heat exchanger. And that steam does what steam does best in a power plant. It spins a turbine, the turbine is connected to a generator, and boom, clean power gets sent out to the grid.
So let's break that down into 4 super simple steps. Step 1, thousands, and I mean thousands of mirrors focus the sun's rays. Step 2, all that focused energy heats up a special fluid. We're talking molten salt or a synthetic oil to extreme temperatures. Step 3, that crazy hot fluid is used to boil water, which makes a ton of high-pressure steam. And finally, step 4, the steam blasts a turbine, making it spin, and that generates electricity. Simple, powerful, and effective.
Okay, so you might be thinking there's just one way to do this, but nope. It turns out there are actually 4 main designs, or as I like to call them, flavors of CSP tech. And each one has its own unique way of getting the job done. Let's start with the big one, the most common and established design out there, the parabolic trough. Seriously, if you've ever seen a picture of a CSP plant, chances are this is what you were looking at. Just picture it, endless rows of these huge, long, curved mirrors. They're all slowly moving together, tracking the sun as it moves across the sky. They're basically like giant lenses, focusing all that sunlight onto one single pipe that runs right down the middle, carrying that special fluid.
Yeah, the parabolic trough is really the workhorse of the industry. It makes up a whopping 78% of all CSP power around the globe. It's proven, it's reliable, and it gets that fluid heated up to a pretty toasty 550 degrees Celsius.
All right, flavor number 2, and this is the one we saw in that incredible picture at the start, the solar power tower. And trust me, this is where things get really hot.
So instead of focusing light on a long pipe, you have a whole field of mirrors. They're called heliostats. And they all perfectly track the sun and bounce its light to one single point at the top of a giant central tower. By concentrating the sun's power 600 to 1,000 times, these things can reach temperatures over 1,000 degrees Celsius. And what does that mean? It means they have the potential to be way, way more efficient.
So this table kind of lays it all out. You've got your parabolic troughs, they're the proven champs, commercially ready, but their efficiency is, okay. Then you have the power towers, which can be twice as efficient, but they're still a bit newer to the game. Then there are a couple of others. Linear Fresnel, which uses simpler flat mirrors, and Dish Sterling, which is super efficient, but is pretty much still in the testing phase.
Okay, now we're getting to the really cool part. The feature that truly sets CSP apart from pretty much every other renewable energy source. I'm talking about its secret weapon. The thing that solves the single biggest problem with solar and wind.
I mean, think about it, right? The sun doesn't shine at night, the wind doesn't always blow. It's the classic problem, the Achilles heel for renewables. So how in the world do you keep the lights on in a city at midnight using solar power?
Well, here's the answer. Thermal energy storage. TESS for short. And this is genius. Instead of trying to store electricity in a massive, expensive battery, CSP plants just store the heat. They pump it into these gigantic insulated tanks filled with molten salt. And that salt can stay incredibly hot for hours, sometimes even for days.
And this, people, is an absolute game changer. It means the CSP plant can just keep on making electricity long after the sun goes down, or even if it's a cloudy day. It provides what energy folks call dispatchable power. All that means is you can turn it on and off whenever the grid needs it, just like a regular gas or coal plant. And that makes the whole power grid way more stable and reliable.
So, with this amazing superpower, you've got to be wondering, where are these things actually being built? Let's take a quick look around the world.
Okay, so right now, as of 2024, there's about 7.2 gigawatts of CSP installed around the world. Now, what does that mean? Well, to put it in perspective, that's enough electricity to power millions and millions of homes, and that number is definitely on the rise.
If you look at this chart, you can see that for a long time, Spain and the US were really the pioneers, the leaders of the pack. But look at what's been happening more recently. The story is totally changing. You see this huge, rapid growth from new players on the scene, countries like China, the UAE, and Morocco. It makes sense, right? These super sunny places are going all in on this tech.
And if you want to see just how big the ambition is here, you have to look at the Mohammed bin Rashid Al Maktoum solar park in the UAE. This thing it's just mind-boggling. It's the largest single-site solar park on the entire planet. They're planning for 5,000 megawatts of capacity. And what's really smart is how they're doing it. They're combining the reliable, proven parabolic trough tech with the super efficient power tower design. The best of both worlds.
All right, let's wrap this up. What does the future look like for CSP? Well, it's a classic story, really. There's a ton of promise, but there are also some pretty big hurdles to get over.
So on the pro side, the biggest advantage is that ability to provide power 24/7 whenever you need it. That is huge. And the basic tech, it's proven, it works. But then you have the cons. The cost to build one of these plants is still a lot higher than just throwing up a field of regular solar panels. Plus, you need a ton of land, and some designs need a good amount of water, which, can be a real challenge in the desert, exactly where this tech works best.
And that leaves us with one last really big question to chew on. As we're all trying to move toward a 100% renewable grid, we know that solving the storage problem is, well, it's everything. So could this be it? Could capturing and storing the sun's raw heat, not just its light, be the key, the missing piece of the puzzle we've been looking for? The answer to that one, well, it could literally shape the future of our energy for a long, long time.